Hello. So we continue with the topic of subspaces. Let me draw one line. So for example, if we have this, I have this line, okay. Sorry. If I have this line, and for example, if I take the coordinates as 1, 2, and then 2, and then there is a point at 1, so 2, 1. So this is the line, and then it is passing through the origin. So from the equation of the line, for example, if the equation of the line is y is equal to mx plus c, where m is the slope and c is the y-intercept, so c is 0 in this case, and the slope is because I have taken as 2 and then this is 1, so the slope will be 1 by 2. So this is equal to y is equal to 1 by 2 x. So this is the equation of the line. So therefore there will be 1 point x2, so 2 1 will be 1 point. So we can represent one of the vector on this line as well by, for example, 2 1 by the vector, okay, or yeah, so we can represent it by 2 1, okay. In this case, our question is whether this line is a subspace or not. Okay, so to answer this, so for example, if we say this line passes through the origin, so that means the vector 0 0 exists on this line, okay. And how about the other vector? If I take any other vector on this line, so for example on this negative side, so if I take, say, a point x is equal to 1, then y will be equal to 1 by 2. So the other vector will be 1 by 2. Okay, so what will be u plus v? U plus v will be 3 by 2. So 3 by 2 will exist on this line. So for example, if I put like 3 x is equal to 3 and y is equal to 3 by 2, so 3 is equal to 1 by 2 times 3, so 3 is equal to 3 by 2. So this line exists on this this point exists on this line, so that means this vector exists on that point. So this means similarly any point, any other combination will exist. So this means that the second condition is satisfied. And for about the third condition, any scalar. So for example, if I take a scalar as 2, so 2u will be 4 and 2. So 4 and 2 will also satisfy this equation. So it will exist on this point. So this means that our answer for this line is that, yeah, so this is a this can be this line can be regarded as a subspace in R2. Okay, so it will be a subspace in R2. Okay, so this is the answer. Next, if we have this geometric shape, something like this, this is y-axis, this is x-axis, and then we have a shaded area like this. Okay, so whereas this point you can take like 1 0. Okay, so it means that this boundary point exists in this shaded in this area. So for example, if this is the shaded area, so this boundary point 1 0 exists on that point. So if I take this u is equal to 1 1 0, and then origin is also there, 0 0 is also there. But if I take, so for example, another point on this, so it will be, for example, here. Okay, so, or maybe I can take another point. So for example, this is the point over here. So suppose this point is 0 1 0 1. Okay, so v will be 0 1. So what will be u plus v? U plus v will be 1 1. So if it is 1 0, this is 1 1. 1 1 may also exist, it depends on the situation. So this may satisfy, but how about the third condition? Okay, so 2 here, for example, 2 times u, so it will be 2 0. So where will be 2? 2 will be here. This point will be outside of this shaded area. So it means that many points may be in this inside of this shaded area, but some other points will be outside of this shaded area. So we will say that as far as this shaded area is concerned, there are some points which are outside of the shaded area. So therefore the shaded region defines it. Shaded region in this case does not define a subspace in R2. So not a subspace in R2. Okay. So similarly, any of these, if the area is limited, so for example, if I have these two lines, and one of the shaded area is here, and the other is here. These two are 45-degree lines, and then at points 4, at the height of 4, so this will be 4 4 point. Okay, so there will be one point over here that will be 1 1, and then there will be another point over here that will be 1 minus 1. Okay, so u11 will be one vector, v1 minus 1 will be another vector. So what will be u plus v vector? So u plus v vector will be 2 0. So 2 0 will be here, which is not inside of this shaded area. Okay, although origin is here on this in this figure, but this point u plus v is not in the shaded area. So it means that it is not a subspace in R2. Okay, and as one more example, if we have this circle, okay, a kind of like a circle with a radius of 3, okay, 3 0 is a point. Okay, this is 2, and then this is 4, this point is 3 0. So if, for example, if I take a vector like u3 0 over here, so 2u is obviously outside of this. So this means that this circle also is not a subspace in R2. So in any way, some of these shapes which are quite confined in some aspects, they are not the subspaces. So not a subspace. Okay, the next example is to find the null space. Find the null space. Find the null space of matrix A. In this case, A is 1 minus 2 0 1 0 2. Okay, so the meaning of null space of A is that null space of A, null space of A is the span of solution, okay, of this equation Ax is equal to 0. Okay, Ax is equal to 0. That means we normally take the solution of Ax is equal to B. Here B is equal to a 0 or null matrix. Okay, so in this case, since there are two rows involved, so we will take a 0. B is equal to a 2 by 1 matrix. Okay, so this is the meaning of null space of A. So what we need to find out over here is that we need to find the solution of Ax is equal to 0. So that means the augmented matrix will be 1 minus 2 0 1 0 2. This is A, and then for the augmentation we need to put 0 0 over here, and then we need to apply the row operation. So minus r1 plus r2, that will be r2. So in this case it will be 1 minus 2 0 0 0 2 2 0. So in this case now we are in the echelon form. So what will be the solution? The solution will be 2x2 plus 2x3 is equal to 0. So in this case we will take x3 as the free parameter equal to s. So 2x2 plus 2s is equal to 0. So x2 will be equal to minus s. And then from the first equation, x1 minus 2, x2 is equal to 0. So x1 minus 2 into minus s is equal to 0. So x1 is equal to 2s. So solution x will be then s we take common, 2 minus 2 2 minus 1 and 1, 2 minus 1 and 1. So while our final answer will be null space of A is span of 2 minus 1 1. So this will be the answer. Yeah, here was small mistake. It should be minus 2s, minus 2. And then there should be a curly bracket over here to represent it like a set. So another more example, null space of this matrix 1 3 4 0 0 2 4 4 and then 1 1 0 minus 4. Okay, so the augmented matrix will be, so we will consider this equation. So 1 3 4 0 0 2 4 4 1 1 0 minus 4 0 0 0. And then so we do a row operation, minus r1 plus r3, that will be r3. So it will be 1 3 4 0 0, and then it will be 0 2 4 4 0, and then it will be 1 minus 1 is 0, 1 minus 3 is minus 2, 0 minus 4 is minus 4, and then minus 4 minus 0 is minus 4, and then this is 0. And the next row operation will be